horizontal urban sprawl has left our cities gridlocked, heavily polluted, and smothered in asphalt. We spend hours sitting in traffic, breathing exhaust. Saudi Arabia's Vision 2030 is a massive economic pivot designed to solve this. To break its dependency on oil, the country is attempting to bypass traditional city building entirely, aiming for a post-carbon civilization built from a blank slate in the desert. This 3D diagram shows how a standard city grid's massive footprint collapses and stretches into a completely different geometry. This is the project's flagship concept, known as the Line. Its proposed dimensions are extreme: 170 kilometers long, 500 meters high, but only 200 meters wide. To hide this massive structure, the exterior relies on a continuous mirrored facade. By concentrating the development into a footprint of just 34 square kilometers, the structure is designed to camouflage itself, reflecting the surrounding desert and coastline. Inside those mirrored walls, planners are pitching a concept called zero-gravity urbanism. The goal is to house 9 million people in an environment completely devoid of cars. By stacking city functions, layering parks, schools, and homes vertically instead of spreading them outward, residents would be able to reach all of their daily needs within a 5-minute walk, moving effortlessly in 3 dimensions. It's easy to render a digital twin in a computer. Dragging a civilization of this scale into the physical world requires transitioning from standard on-site building to high-volume industrial manufacturing. Far from the peaceful concept renders, the current excavation phase is violent. Right now, massive mechanical giants are actively chewing through 28 kilometers of solid granite beneath the desert floor. They are excavating the spine, the hidden subterranean heart of the city that handles all transit and logistics beneath the pedestrian level. This deep rail and maglev infrastructure is being engineered so citizens can travel from the coastal edge of the city to the mountain terminus in just 20 minutes. Down in these tunnels, an autonomous AI logistics network monitors its own structural health and delivers goods silently, acting as the city's veins. Above ground, at Oxagon, NEOM's floating industrial port, human labor limitations are a significant bottleneck. To solve this, developers are partnering with companies like Samsung to automate the heavy lifting. Advanced AI-driven robots are now automating the assembly of massive steel rebar cages. This removes humans from high-risk manual labor and cuts the required workforce for this specific process by 80%. The sheer physical volume of the line cannot be built by traditional methods. Forcing this city into existence requires an army of automated machines working at an industrial scale. This raises an immediate survival question. How do you generate enough power and water to sustain 9 million people in a wasteland without emitting carbon? The answer lies in the Aqua Power Green Hydrogen project. This 4-gigawatt solar and wind venture has reached 80% completion across its generation grid. That power feeds a network of desalination plants and ocean-cooled data centers. These facilities act as a nervous system for the city, managing power and water with precision so that energy waste is minimized. To survive out here, NEOM must operate as a perfectly closed-loop survival engine, powered entirely by renewable energy and high-speed data networks. This chart illustrates the collision between ambition and economics. Planners initially projected a $500 billion budget. Recent reports suggest the actual cost has risen to a staggering $8.8 trillion. This financial reality forced a strategic pivot known as the 2026 recalibration. Planners are shifting to an operational-first mindset, prioritizing what can be financed now. On this map, the 170-kilometer vision is reduced to a 2.4-kilometer sliver at the coast, designed to house 300,000 residents by 2030. The friction of the real world, the limits of physics, logistics, and capital, has forced the utopian blueprint to fracture into slower, staged phases. We are already seeing the casualties of this friction. Major projects like the Moonlight desalination plant have been canceled, and contracts for the Trojana dams were terminated in early 2026. Internal estimates now suggest that completing the full 170 kilometers could take 100 years. There is a very real possibility it may remain an unfinished fragment. But whether it finishes or not, the attempt has turned this region of Saudi Arabia into the world's largest extreme engineering laboratory. This attempt forces the standardization of robotic assembly for infrastructure and provides a testbed for the world's largest green hydrogen grid. These are specific engineering results that are being proven in the field right now.
The processes refined here, from autonomous rebar fabrication to the management of 100 terabit data networks, will exist as a technical blueprint for the next generation of infrastructure, regardless of the final length of the mirrored wall.